Welcome back, grade 8. Term 2, things are heating up. Today what we're going to be doing is expression. A little bit stressed, don't really know what to do with your maths, but we're here. We're here to stay and we're here to help you. So what are expressions? Well, now that we started tackling algebra, the teacher now starts talking about algebraic expressions. What are they? What do they mean? And all of a sudden they start throwing words like this at us. Terms, coefficient, degree, to what degree, variables, and exponents. These are all the words we'll start hearing when we talk about algebraic expressions. And then of course the big one is the plus and minus signs, which are things that separate our terms. We're going to get stuck into that, and I'm sure you'll know exactly what's going on when I'm done with you today. Alright, so what I've got on the board here is an example of an expression. So the question is, what makes this an expression? Well, an expression, alright, an algebraic expression in mathematics is made up of terms, okay? Now, terms are things like this. If I had to have, for example, let's ignore this example now, let's talk about this. If I had 4a squared, this over here is one term, alright? It's got a coefficient. It's got the coefficients, alright? My coefficient is the number that stands in front of my variable. So this a over here, the letter, alright? The unknown is known as my variable. We do not know the value of this a, so it's a variable. It can vary. We don't know exactly what it's worth. But the letter that we have in mathematics or in algebra is called my variable. And then I've got this little 2 over here, and the 2 is what the a has been raised to. It's a squared, a to the power of 2. So this is known as my exponent. So those are 3 of the words that I brought up in the first frame of this video and explained that. So now exponent is what my variable is raised to, and my variable, of course, is the letter that we have in algebra, and my coefficient is the number that stands in front of my variable. Almost like a co-pilot stands next to the main pilot here. It's the variable, and then I've got my exponent. Now this in maths is called a term. It's one term. Now we can glance back up to the top, and we notice how I told you that this is called an expression. What makes it an expression? Well, it's made up of different terms. Now the next question is going to be, well, how do I know which one is a term here? Well, this is the biggie, because terms are separated by plus and minus signs. Plus and minus signs. So if I had to ask you how many terms are there in this expression up top, you would say to me, well, here's one term. It obviously stops now because I have a minus sign. Here's another term, all right, plus sign, so it separates. Here's another term, another plus sign, and another term. And I'll just count them. There's 1, 2, 3, 4. There are 4 terms in this above expression. So this is an expression in mathematics. This is what a simple term looks like, and these terms are what make up expressions. And there are special names for the different types of expressions that we have. If there is one term in an expression, so we got one term, that's going to be called a monomial. Monomial. 2 terms, it's called like a bicycle with 2 wheels, it's called a binomial. Alright, then we got 3 terms, similar to a triangle. It's called a triangle because it's got 3 points, okay, or vertices, but that would be on an object. But 3 terms would be called a trinomial. Alright, a trinomial. And then 4 terms, 4 or more terms. Can anyone guess what 4 or more terms will be called? Well, I'll tell you, it's called a polynomial. Alright, it's not a quadrinomial like some of you might have guessed. It's called a polynomial. So 4 or more terms will just be called a polynomial. I hope that makes sense. 1 is mono. 2, bi. 3, tri. And 4 or more is polynomial. Alright, I hope that sinks in. Alright, so I'm going to shoot through a couple more sort of interesting things about expressions and the questions that we get asked in papers. Now, I'm going to keep the same example on the board so we stay familiar with it. We've already identified with this expression as to how many terms there are. How many terms? Well, there are 4 terms in this expression, as I've said already. So the next question, that is a pretty standard question, and I'm going to try to go through all the questions so we can highlight the different aspects of this expression, would be, what is the coefficient? What is the coefficient? What is the coefficient of the b cubed term? What is the coefficient of the b cubed term? Now, this is asking us to cast our eyes over to the term which has a b to the power of 3, but as you know, if it's to the power of 3, you can also say b cubed, alright? Like if we have something to the power of 2, I would say that that is 6b squared. You can say 6b to the power of 2, that's fine, but you'd rather say 6b squared, okay? And this is b cubed. So it says, what is the coefficient of the b cubed term? So I now need to try and find out, where is this b cubed term? So I look at this one over here, 14b, no, over here, b, here it is. So look how I highlight the entire thing. And we can take it downstairs over here, just so we can look at it together. I've got a positive b cubed. Now, I've highlighted this as my question for a certain reason. And the reason being is that right now you can't see a coefficient. So we've got 4a cubed. It's just another example to show you again. And my a is my variable, alright? My a is my variable. The 3 is my exponent. And the 4 is my coefficient. Sorry for the repetition, just to make sure it does sink in. So we know that our coefficient is the number that stands in front of the variable. Now, again, I think I'm going to use a different color for this b over here, just so you can see it nice and clearly. I've got a positive b cubed. Now, what you've already figured out with maths and with algebra is that if I have a variable, it simply means I have one of them. Alright? If I've got a, like this, oh, let's use a better color, sorry. If I have a, how many a's do I have here? I have one a. Now, we can put a 1 in front of that a, but it's not necessary because we can only see one a. It's only when we start getting to 2a that we know we have 2 a's. Or I could say I have 10a. It means I have 10 a's in my hand. So when we just find a variable without a coefficient, there's always an imaginary 1. Always an imaginary 1. So the coefficient of my b cubed term is going to be 1. But the thing we need to really focus on and understand is that, look how I highlighted the positive sign here, the plus sign in front of this term. Why have I done that? Well, it's very important. If it's a plus 1, my answer to this question over here, what is the coefficient of the b cubed term, would simply just be 1. Because 1 is positive. 1 is 1. That's fine. But if, for instance, this is not, for instance, for example, I'm making up an example again. If this sign over here was a negative b cubed, lots of learners get really stuck on this and they go, oh, Michael, it's the coefficient of this b cubed term is 1. No, it's not. The coefficient of this b cubed term is actually negative 1, alright? So we have to write the answer as negative 1. Very important. That's a simple way of the teacher trying to trick you, and it happens year after year after year. When they ask you questions like this with an expression, they're always going to try and give you one with no coefficient, because it's an imaginary 1, and they'll often throw in a negative to really try and throw you off. So the answer to this question over here, just to get back to it, would have been 1. Okay? The answer to what is the coefficient of the b cubed term? The answer is 1. Equal to 1. That's the answer. Now, that's dealing with coefficients. While you're sitting there, I'd like you to try and identify the coefficients of all the other terms. So what would the coefficient of the b squared term be? Or when I look at find b squared, there it is, the coefficient is 6. There's no signs in front of it, so it will be positive. I then go across, what is the coefficient of the b term? Well, that's going to be 14, because 14 lies next to this b, alright? And there's a positive sign, so it's just going to be 14. I only really need to look at that if there is a negative sign. That's when we're going to get confused. So, the next standard question that they like to ask you is, what is the degree of the expression? What is the degree of this expression? Now, this is something we just need to really understand and remember, because when they talk about what is the degree, it's to which power, raised to which power is this expression? What is the highest power that we have here? So when they're asking you what is the degree of this expression, or a expression, any expression for that matter, we just need to try and find our highest power, our highest exponent. Don't be confused between the two words. I can say power or exponent. They mean the same thing. So I'll just look through my terms and I'll try and find the variable with the highest power. So first off, I've got a 2, okay, so that's right now, nothing here. 3, nothing else, so 3 is now my winner. So I'm going to say that what is the degree of this expression? I'm going to write down my answer as the third degree. Third degree, that's my answer. I'm looking for the highest power, and it happens to be a 3, so my answer to the question is third degree. If my power was a 6, the highest power was a 6, I'll say the 6th degree, or 7th, or 10th degree. The highest power is what my degree of an expression will be. Alright, so the next question we have here is, what is the constant term? What is the constant term in this expression above here? So, I've underlined the word constant because that's what I want you to focus on. I want you to understand what constant means. So you've heard me now speaking about a variable. A variable is my letter that we find in algebra. A variable is something that has a hidden value. We cannot see it right now. That's why it's called a variable, because it could vary. We don't know what it is right now. But that's why it's called a variable. Now, a constant is almost the complete opposite. A variable is something that we don't know about. But a constant is something that we do know about, because it stays the same. It's like your little brother or sister. They are constantly annoying you. They're always annoying you. Okay, it's there. It's in your face. So a constant term is something that's not going to change. Now, if we were to think about that logically, well, surely it's going to be something that does not have a variable, because a variable would certainly change a value of something. Because if I had 4b, that's not actually just 4. Because what if I said b was worth 2? That would mean it's 4b, 4 times b, 4 times 2 is 8. So it's not actually the value we think it is. But with a constant, it will remain that value. It does not have a variable. So I cast my eyes, 6b squared, b cubed, no, 14b. It's got to be this right here. Now notice again how I've highlighted the sign in front of my term. So here it is, -2. -2 is going to be my answer to the question. -2 is my constant term. I can't just say 2. Yes, it doesn't have a variable, and that makes it the constant term, but it's not just 2, it's -2. And there's a big difference between 2 and -2. They're just not the same thing. So my answer to what is the constant term, it's going to be -2. Another standard way that they can trick you out in a maths paper, and that's why I've included in this example, to make sure that we keep highlighting the entire term. By entire term, I mean whatever sign is in front of it, a positive or a negative, needs to be included with my term. Otherwise, I'm going to find myself writing the answer as just 2, which would not be right. So a constant term is something that remains constant, it remains the same, and it does not have a variable. Alright, so the next question reads, rewrite the above expression in descending, and I'm going to highlight this over here. Descending, that's very important. Descending powers, again very important, of b, again very important. So I've now highlighted the important things, as I've said, in this question. Rewrite, they want us to rewrite the above expression, okay, so we have to rewrite it, and they want it in descending powers of x. Now descending is if we're going downhill. So descending, all right, descending is starting at the top, right, with the biggest, and heading down to the smallest. That's descending, almost like you're going down, descending down. So you're starting with the biggest and you're going down to the smallest. Ascending would be the opposite. Ascending is when you're climbing up from the smallest to the biggest. So you start with the smallest, end with the biggest. That's ascending. Descending is starting with the biggest, going down to the smallest. So let's cast our eyes back now to this expression. If we look at our powers, let's look at our powers or our exponents. B squared, great. B cubed, great. I skipped the constant because it does not have a B term. B, all right, does not have a power or an exponent. What does that mean? Well, again, just like I said earlier, if I have A, right, I'm not going to write 1 in front of it. I'm not going to do this because I know that it's just 1A anyway. It's not necessary. I can do it if I need help with it. That's fine, but I don't need to do it. Same as a power. Anything to the power of 1 remains the same value. So there's no need for us to put it there. That's why we won't find that in maths. But if we need to put it there, that's absolutely fine. It's going to help us with the simplifying of expressions. But right now, we're just doing some identification. So let's ignore that now. And what I'm trying to say to you is that if you want to put the 1 in here, you're more than welcome to. Not a problem if it helps you in a situation like this. So now, let's get back to the question. It says, rewrite the above expression in descending powers of x. Well, what's going to happen first is the variable with the highest exponent. And that's going to be a positive b cubed. So I can almost erase that and now have b cubed. I don't put the plus sign here. It doesn't make sense to do that. But if it was a minus sign, I would have to do it. Then, that's done. What's the next one? It's going to be plus, it's a positive, plus 6b squared. And then I've got another plus, and I've got 14b. And last but not least, it'll always be your constant because your constant doesn't have a power, hasn't got b to the power or anything. So my last one is going to be minus, all right, my constant, which is 2. And that's my answer. B cubed plus 6b squared plus 14b minus 2. That is rewriting this expression in descending powers of b. Alright, so the last question that I always like to ask you in tests and exams when you're dealing with expressions is, well, now that you know this, Michael, okay, let's really test you. Now, what is this worth? What is this worth if b is equal to negative 2? All of a sudden our variable has a value. It's come alive. So let's try and work this out. Now, trick number 1. Whenever you see this, b is equal to negative 2, we now know that our variable has a value. Our variable has a value. I'm going to rewrite it quickly because it's got a bit of a mess up there because of what we've done. 6b squared. And you know what? I'm actually going to do it in a different color just to make sure you guys know exactly what's going on. So if I have 6b squared, right, minus 2 plus, make sure the b is in red to make sure you know what's going on, plus b cubed plus 14b. Right, now, my trick to you, my tip to you, it's my trick, it'll be a tip for you, is that I always like to now take this b away, okay, and it's known as substitution. Substitution. Something you should all be familiar with, okay, something you're not always too happy about, but whether in the water polo pool or on the netball court or on the soccer field, and you get substituted, it means you come off and your friend goes on, or maybe it's not your friend, but someone goes off, someone goes on. It's substitution. So what you're doing here is you're substituting our b, all right? We're throwing our b out of the field or the court, and we're putting the negative 2 in its place. Now, whenever we do this, we don't just put a negative 2 here. Okay, I don't just write this. I don't go 6 negative 2 to the power of 2. Definitely not. Okay, because that wouldn't make sense. What we need to do is we need to replace it, but replace it in brackets. So now I'm going to have 6. I'm now subbing in my negative 2, so I'll put a bracket, because there's a b, negative 2, close the bracket, square. Minus 2 plus, here's my b, bracket, negative 2, close it up, power it up with the 3. And we go plus 14, oh, there's another b, bracket, negative 2. Right, step by step, always the best. Now I need to multiply this out. So, I have 6 bracket negative 2 to the power of 2. In life, who are the people who get treated the best? Now when I say that, I mean people with power. People sitting in government or parliament high up, or if you're in England, you've got the royalty. Those people always seem to get first choice. So whoever sitting higher up must be dealt with first. Well, the 2 is sitting a lot higher than the 6. What I'm trying to say is, if you've got a power, you power up your bracket first. Then you multiply it. So you've got a couple more steps to do. So if I want to power this up, that means negative 2 squared, which means negative 2 times negative 2. Remember, a negative times a negative gives me a positive. So I rewrite my 6 bracket. What's happened now? It becomes positive 4. Minus 2. Nothing happened there. Now, what is this going to be? Well, I've got negative 2 raised to a cube. That means negative 2 times negative 2 times negative 2. As discussed, if we've got a negative raised to a power, which is odd, my answer is going to stay negative. So this is going to become negative, what's 2 cubed? 8. So it's plus bracket 8. I'm not going to get rid of it just yet, negative 8, sorry, because I want to show you what happens here. We move forward, and I've got a positive 14 multiplying into the bracket with a negative 2. Lots of students like to just do this before they even do this multiplication. Don't do that, because you don't know, your answer might become negative, which is what we're going to see right now. So I've got a positive 14 multiplied by a negative 2. I always like to do the sign first. Positive times a negative is going to give me a negative. 14 times 2 is 28. Right, now let's get rid of this. So now I've got 6 times 4, which is 24, minus 2. A plus times a negative is going to remain negative, so minus 8 minus 28. I mean, I'll just simply need to make our way, sorry, the color's not doing too well, across. 24 minus 2 is 22. So 22 minus 8 minus 28. 22 minus 8 is going to give me, what's it going to give me? What's it going to give me? 14. So 22 minus 8 is 14. Now still going to minus 28. And that's going to give me negative 14 as my final answer. I hope that makes sense. Russell, can you see the answer? If you can't see it, they can't see it. Can you see the answer? Yes, please. Right, there we go. So that's wrapped up. What I'm going to do for you now is I'm going to put your own example on the board. I'm going to fire up the questions below, and you need to let me know if it makes sense. Have I missed any steps here? Maybe I have. It doesn't matter where I have missed them. You let me know right down below so we can interact. And I'll let you know anything you need to know. That's why I'm here. I'm your tutor for free. Alright, so the question is 3p plus 5p cubed minus 3 plus 7p squared. That's my expression. It says, number 1, rewrite the expression in descending powers of p. Number 2, what is the constant term? Number 3, what is the coefficient of p squared? Number 4, write down the degree of the expression. Number 5, find the value of the expression if p is equal to 2. Little bonus question, how many terms are there? How many terms are there? Remember, what are terms separated by? Plus and minus signs. Kick on. Good luck.